Laboratory and also the parent department of ISRO. His aim was to organize task-oriented projects for the nation's practical problems. And today when we look back, his vision was very great and we have achieved, ISRO has achieved the success of landing the Chandrayaan-3 in the south pole of the moon. And coming to the Plasma Research Laboratory, I was fortunate to spend one year in the Physical Research Laboratory, which is also the mother department of Institute of Plasma Research. In 1970s, the Institute of Plasma Research was separated from Physical Research Laboratory. And also, all of you know, the plasma research, their contribution to the tokamak. The first tokamak was built in Plasma Research Laboratory, which is called Aditya. So the future of energy is in the thermonuclear reactors, which we call as the tokamak. All of you know what the process in the sun happens. You have the nuclear fusion, which produces energy, which is the source of energy in sun and the stars. So the question is whether we can reproduce the sun within the laboratory. And all of you know, many countries have joined together to have an international thermonuclear experimental reactor, which is known as ITER, which is the Latin word of ITER is the way. And India is also a partner in this ITER project, where you have the thermonuclear fusion, fusing deuterium and tritium, which will produce energy. So to make a fusion, initially you need a very high temperature, like 150 million Kelvin temperature is needed to make fusion. So how to produce such a high temperature where the deuterium and tritium can combine together and it will produce a helium along with the neutron. So it's a thermonuclear fusion reaction. And to make the plasma sustainable plasma, it's a difficult job. And basically tokamak is to confine the plasma. Plasma means the ionized state, fourth state of matter, where you have the ionized atoms and electrons. So you have to confine this plasma, which require very high magnetic field. So you have a toroidal shape and toroidal plasma where you have a high magnetic field. So if you want to produce a high magnetic field, normally you have to use electromagnets where you have to pass very high currents. So you need a superconducting coils. So to have a superconducting, you need a very low temperature. And the whole system is under vacuum at a low pressure. So what I mean is everyone has to join together. Cryogenics, magnetic people, engineers, electrical engineers, vacuum experts. Everyone has to join together to produce this toroidal plasma, where you can produce this nuclear fusion, and the neutrons will carry 80% of the energy, which will impinge on the walls of the plasma chamber, and it produces the heat, and you can circulate water to produce steam, and then you will produce energy. So in 2035, India is also partner, the ITER project, which will produce a 500 megawatt energy. That is the aim of ITER project. So this is something what Vikram Sarabhai has visioned. We need to have a project, task-oriented projects. And India is very good in it. One typical example is ISRO. We have Department of Atomic Energy. Now we have the Plasma Research Laboratory and zone. and also DRDO also doing very well in the mission-oriented projects. So I would like to read one of the article which came in the Washington Post. The number of women engineers in the mission control was inspiring. They are talking about the ISRO's Chandrayaan 3 mission. The number of women engineers in the mission control was inspiring. In traditional clothes, with the dots on their forehead and flowers on their hair, speaking in British accent English, careful to avoid grammatical mistakes, giving the commentary, calling out the status reports. Another important thing is all those engineers were from the so-called second string of engineering colleges of India. The graduates of top engineering schools, prestigious IITs, IICs were largely absent. The first echelon of Indian engineering talent is scooped by the companies like Apple, Google, Amazon, and Microsoft, the big multinational companies, and the prestigious MBA schools. It shows the depth of talent in India. It can afford to give any top branch and still have enough left over to solve the land space craft in the moon. Okay, we have enough talent. Even though we have many IITs and IICs, they may be joining in the multinational companies. It is difficult to get an admission into IIT. Rather than you can get admission into MIT, it's easier than getting admission into IIT. Because we have a large pool of talent and everybody is competing to get an admission to IIT and prestigious institutes like NIT. And as the president of the function has pointed out, India is the youngest country. If you take the average age of Indian population, it is only 28.6, considering Japan, which is around 46. So we have a large human resources which are very young. And it is in your hand the future of the nation belongs. I have read the quote from the Washington Post. The older generation, their contribution has resulted to the success of Chandrayaan 3 and Aditya 1. Now it is your turn. You are young talent and you have to come up with ideas, and basically in basic science you have to have a deep knowledge and which has to be applied. That is what is one of the vision of Vikram Sarabhai, who told that we have to do task-oriented projects for the nation. So I am sure that you youngsters have curiosity to know more about what is happening in the India and especially in plasma science. And I am sure that you will be the next generation who take India to the developed nation. When I say this, when we call a country as a developed nation, there are many ways to measure the development index. One is called the Human Development Index, HDI, which is at present India is very low. And one measure of HDI is the number of researchers per lakh of population. And if you take a country like Denmark, which has 600 researchers per lakh of population. For example, Canada, which has 97 universities, 450 researchers per lakh of population, and the total population in Canada is just above what we have in Kerala. It's only 3.9 crore. And they have 450 researchers per lakh of population. But coming to India, we have a large populous country, and the number of researchers per lakh of population is only 25 as per the 2018 statistics. So this is a very meager number. So I expect in the next 10 years, this number has to be at least multiplied by 10 times, at least to reach country like Malaysia, which is not so developed, It has 67 universities and 250 researchers per lakh of population. So this is a huge number. So the current strength of researchers in India has to be multiplied by at least 10 times. And I think that the young population sitting in front of me will take up a scientific career which will build the nation India. And I want to conclude one of the reminding what Professor Prasad Krishna has told, curiosity. One of the, in our constitution, only in our constitution, the word scientific temper is included, which was included in 1942 as a 42nd amendment in 1962 also. The reason I am not going to the reason for that, what is scientific temper? Scientific temper is you have to observe things and experiment it. So repeated observation and experimentation, derive a conclusion by analyzing it. So observe and experiment, then analyze and derive the conclusion. And that conclusion you have to disseminate into the society. That is what is meant by scientific temper. You have to ask questions, you have to observe, you have to experiment it, derive at the conclusion by analyzing it, then disseminate into the society. So that is a fundamental duty which is included in our constitution, and it is only in Indian constitution this scientific temper is included. So it is your duty to observe, experiment, analyze, and whatever results you get, you have to disseminate into the society. This is very important.